Hi, my name is Stone. I'm a software engineer here at Ragie.ai. If you haven't heard of us, Ragie is a fully managed RAG platform for developers. I've been working extensively on the Model Context Protocol. Our approach to MCP at Ragie is unique given our nature as a multi-tenant knowledge-based repository. This allows us to offer richer, more granular information about the contents of the knowledge base compared to generic implementations, thereby alleviating a significant pain point when building with MCP. Today, we'll discuss the current landscape of building MCP servers, the inherent challenges, the solutions we've implemented at Ragie, and what the future holds for the entire ecosystem. There are three main pain points I want to discuss today. Initial setup and connectivity, going from 0 to 1. Establishing the infrastructure and ensuring connectivity remains complex. Making tools easy to use. Creating tools that are genuinely useful is difficult, namely because of one problem we'll dig into. And last, rough end-user experience. The current end-user experience leaves much to be desired. Now, before we jump into that, some background about MCP. The Model Context Protocol was introduced by Anthropic just less than a year ago in November of 2024. The goal was to standardize the way AI applications communicate with one another and, specifically, eliminate the need for vendor-specific connector solutions like OpenAI's function calling and ChatGPT plugin framework. Now, going from 0 to 1. We'll start with authentication. A critical observation, and one that surprises most developers on day one, is that the majority of MCP clients, including ChatGPT and Claude Desktop, do not support API key authorization. That means you can't send an authorization header. You usually can't attach custom headers at all to configure your server connection. Because of these limitations, OAuth has quietly become the de facto standard for MCP, even though it's not a part of the specification. Major clients like ChatGPT and Claude only support OAuth-based flows for connecting external MCP servers. Implementing OAuth isn't as simple as adding a few headers. It requires registering your server as a valid OAuth client, implementing redirect URIs, exchanging authorization codes for access tokens, and securely persisting those tokens per session. So if your infrastructure wasn't designed around OAuth from the beginning, integrating it later is non-trivial. And if your auth provider doesn't support OAuth for MCP, you're basically out of luck. At Ragie, we had to address the OAuth issue because all of our APIs, including the MCP servers built on each partition, use API keys for authentication. To do so, we used our open source chat application, BaseChat. The Ragie platform is for developers, and BaseChat is our open source reference app powered by Ragie that lets users chat with their data in an instant. We implemented an MCP server within BaseChat to allow end users to authenticate themselves using OAuth and act as a proxy to the MCP server in Ragie platform. BaseChat uses the BetterAuth library, which, luckily, does support OAuth for MCP. Implementation across different clients. Development often requires testing with various clients. While Anthropic's MCP inspector tool offers a straightforward starting point, it carries some limitations such as the inability to handle HTML responses during the OAuth handshake, a common occurrence when using authentication providers. Transitioning to clients in production introduces further complexities. Surprisingly, ChatGPT imposes specific requirements for MCP servers hidden in one of their guides. These requirements mandate the implementation of two specific tools with predefined input and output schemas, which deviates from the open standard ethos of the Model Context Protocol. At the very least, adhering to these client-specific schemas requires refactoring, and in some cases, this rigid structure imposed by the client may make no logical sense when juxtaposed with certain MCP servers, rendering the entire collaboration moot. Other clients, such as Cursor, utilize a JSON file for configuration. Claude Desktop does the same, but developers will discover that Claude actually requires the npx command in the config to use the MCP remote package. This serves as a local proxy to expose a standard I/O interface to the Claude client. This essentially negates the benefits of implementing streamable HTTP in MCP servers, as the MCP remote proxy needs to buffer the incoming server information into complete messages before sending them to the MCP client through standard I/O. This adds overhead, increases perceived latency, and can degrade the user experience for long-running connections to AI agents. Now, the Wild West. The MCP ecosystem is essentially the Wild West. The official Python SDK, a fork of FastMCP, lags behind in features and community support, and is notably sensitive to URL formatting, causing issues like broken redirects and failed OAuth flows. In contrast, Fast MCP offers a more robust and comprehensive set of features, including server composition, proxying to arbitrary MCP servers, automatic server generation from open API specs, enterprise-grade authentication, enhanced client infrastructure for LLM sampling, in-memory transport for testing, and dynamic tool rewriting. The discrepancy between the official SDK and the Fast MCP SDK highlights how fragmented the ecosystem is and poses a serious challenge for developers when navigating how to get started. As more tools and SDKs become available, developers shouldn't have to question whether the tool they choose to use will continue to be supported or lag behind others in features. Another barrier to entry for developers is the requirement for paid accounts on platforms like ChatGPT or Claude to even integrate or test these features. Just for the ability to add a custom MCP server URL, users must be on a paid personal or organizational plan, again undermining the free open standard nature of the Model Context Protocol. Going back to our implementation at Ragie, using BaseChat as our OAuth proxy. Like I said, we use the BetterAuth library. And here we have a great example of the challenges during development. BetterAuth provides a guide in their docs to set up the MCP OAuth plugin. It outlines how to set up the API routes for the OAuth handshake, like the discovery metadata and the protected resource metadata. However, developers can run into issues depending on which client they're using. For instance, ChatGPT performs the handshake with these API routes using GET requests, whereas the MCP inspector tool will use the HTTP options method. Now, once identified, the discrepancy is an easy fix, but the presence of the discrepancy again highlights the Wild West nature of the ecosystem and goes against the open standard ethos of MCP in the first place. The deeper problem here isn't just technical, it's philosophical. MCP was envisioned as an open standard, a way to democratize how AI applications connect and collaborate. But when developers need a paid ChatGPT subscription or an enterprise cloud account just to test a basic MCP handshake, that vision starts to crumble. The barrier to entry doesn't just slow innovation, it gatekeeps it. And the fragmentation across SDKs and each client interpreting the standard differently just adds another layer of instability. You shouldn't need to juggle different interpretations of the same protocol just to ensure compatibility with competing vendors. These inconsistencies don't just inconvenience developers, they undermine trust in the protocol itself. Until the ecosystem aligns around truly open access and consistent behavior, MCP will remain more of an experiment than a standard. Now, making tools easy to use. We'll start with the tool routing problem. MCP promised seamless integration of external functionality into LLMs. However, in practice, exposing generic tools like search, retrieval, or knowledge base often leads to suboptimal performance. Agents frequently struggle to determine the most appropriate tool to use because vague labels provide insufficient signal regarding the relevance of results or whether to consult the web or other sources. This ambiguity often necessitates explicit instructions from the user, such as use the retrieval tool to answer this. Client performance and tool selection vary significantly. Cursor performs okay when selecting which tool to use, but Claude, for example, is lacking. The common underlying issue across all the clients is the tool routing problem. To mitigate this, clients like Cursor have introduced rules, hard-coded instructions applied before each query to ensure specific tool usage. While this offers a workaround, it's a clunky solution that requires manual setup, scales poorly across diverse contexts, and disrupts the natural conversational flow. One possible solution when developing the MCP server is to simply write much more detailed tool descriptions, and this will solve the problem when developing the server for a single tenant. However, in a multi-tenant environment, it becomes impossible to provide accurate descriptions of the knowledge base for each tenant at scale. Enter context-aware tools. By dynamically generating descriptions based on the actual content or schema available, these tools advertise their capabilities in a way that significantly improves LLM decision-making. Instead of a generic retrieval tool, a context-aware description might read, retrieve HR compliance policies and employee handbook content. Similarly, a vague text-to-SQL tool could become query financial transactions and invoice records from Postgres. These richer, context-specific signals provide the LLM with the confidence to select the correct tool without explicit user guidance, leading to more accurate and seamless interactions. At Ragie, we provide a hosted, streamable HTTP MCP server for every partition. Each server exposes the retrieve tool that performs the retrieval scoped to the server's partition. Each partition has a description that is constantly being dynamically updated based on the content of the documents inside. As documents are uploaded, updated, and deleted, the partition description and therefore the MCP tool descriptions are updated to accurately reflect the most up-to-date information. This gives agents real-time, accurate descriptions of the tools at their disposal and the confidence to pick the right tool for the job. To make context-aware descriptions possible, we had to rethink how MCP servers expose their tools. In the standard model context protocol, the list tools command returns a static set of tool definitions, each with fixed descriptions. That works fine for simple single-tenant setups, but it quickly breaks down in multi-tenant applications like Ragie, where each customer's knowledge base is unique. Our solution was to make list tools dynamic. When an MCP client asks for available tools, the response now depends on the tenant tied to the API key that made the request. Behind the scenes, we sample and summarize content from that tenant's knowledge base and update the tool descriptions on the fly. So instead of seeing a static retrieval tool, a user connected to a compliance dataset might see retrieve HR policies, employee handbook details, and data retention rules. To build this, we have created an open-sourced small library called Dynamic FastMCP. It extends the official Python FastMCP server framework by making it easy to plug into protocol-level commands like list tools and generate the results dynamically. With Dynamic FastMCP, you can define dynamic tools whose descriptions are resolved at runtime, taking into account the user, tenant, or request context. This design is particularly helpful in multi-tenant SaaS environments where one MCP server may be serving hundreds of different customers, each with different data domains. Now, what's important to understand is that Dynamic FastMCP isn't a fork or protocol hack. It's an additive layer that sits cleanly on top of the official FastMCP Python SDK. There are no protocol changes, no client modifications, and no surprises under the hood. We simply subclass the SDK's FastMCP server and tool manager so we can compute tool descriptions at request time while still speaking the same MCP types clients already understand. It's built entirely on FastMCP primitives. That means we're still using the official SDK's abstractions like tool and tool manager. If you've ever built an MCP server before using FastMCP, your code will look and feel the same. We've just made it more flexible. The protocol stays the same, but the results become dynamic. Instead of returning a static list from list tools, Dynamic FastMCP calls each tool's handle description right before responding, merging those context-aware descriptions into the normal tool list. Clients still receive standard tool payloads. The only thing that changes is that those descriptions now adapt to the tenant or user context. Request context remains first class. We use the SDK's built-in context object to identify which tenant a request belongs to, pulling that from the API key, threading it through the entire description generation process. So we're not reinventing authentication or request handling. We're building directly on the same context model FastMCP already supports. And of course, it's fully multi-tenant ready. Because we generate descriptions on demand, one dynamic FastMCP server can serve hundreds of tenants at once, each seeing tools that reflect their own data domains without breaking the MCP contract. This works seamlessly across the transports the SDK already supports, including ASGI and streamable HTTP. Finally, it's aligned with the ecosystem. FastMCP is the actively maintained framework most developers use. Dynamic FastMCP follows that same model. We extend, we don't replace the SDK services. So what does that mean in practice? It means you can keep your existing clients. Tools like Cursor, Cloud Desktop, or ChatGPT, they all work exactly as before. They'll still call list tools and call tool normally. Features like Cursor's rules still work, but you might find you need them less because the tool descriptions themselves now carry intent. You can also keep your existing server code. Your mcp.tool functions still work exactly as they do today. You just add dynamic tools by subclassing dynamic tool, which lets you define a handle description method for generating descriptions on the fly. Everything else, parameter schemas, outputs, Pydantic validation, continues to flow through the same SDK plumbing. And the upgrade path is gradual. You don't need to rewrite your server. Just start by mixing in one dynamic tool alongside your static ones. If you like how it improves discoverability or context routing, you can migrate more over time. One tool at a time without breaking anything. Now, the end user experience. I believe the biggest reason for the disparity between the number of MCP builders and MCP users comes down to one thing: the end user experience. Let's start with the setup. In most clients, MCP configuration is buried deep in advanced or developer settings. It's not discoverable, it's not documented, and when users do find it, the experience feels unfinished. You enter a URL, maybe a server name, maybe a redirect, and then nothing. You get a vague disabled message or disconnected, or worse, the enable button is grayed out for no reason. There's rarely any helpful feedback. No validation errors, no progress indicators, not even a hint at what went wrong. It's just silent failure. Cloud Desktop is a perfect example. If your connection fails, you have to restart the entire app just to retry the handshake. It's easy for us as engineers to dismiss this as UI polish or edge case handling. But when the first interaction with your tool feels confusing or broken, that's where adoption stops. Here's the part many developers overlook. If your users can't successfully connect to your MCP server, your tools might as well not exist. MCP is a bridge between AI and your product, but if the bridge collapses on first click, no one will ever cross it. The clean, predictable UX isn't just aesthetic, it's an adoption multiplier. Every smooth onboarding experience means more users exploring your tools, giving feedback, and validating your product. Every confusing step is an exit point, and right now, MCP has too many exits. We're all developers here, so we know the feeling of shipping something technically correct, but functionally frustrating. MCP clients today often give us that same energy. It works on my machine, but users don't care about protocol correctness. They care about whether it feels like it's working. So the question becomes, are we building an open protocol for AI systems, or are we building something that people will actually want to use? Because those are not always the same thing. OAuth flows. Once users do manage to find the right settings, they're met with another barrier, the OAuth labyrinth. The flow usually goes like, the user clicks connect, the client opens up a new browser tab, then another tab, and then a blank redirect, and then finally a login page from a seemingly unrelated provider. At no point does the interface explain why the user is logging in or that this is specifically for authorizing this MCP client to this server. It's a leap of faith. Users are trusting this strange sequence of tabs and redirects is legitimate when all visual cues are telling them the opposite. And after they log in, they're dropped back into the client. No success message, no confirmation, just back to where they started. Did it work? Did it fail? Who knows? This doesn't just cause confusion, it damages trust. OAuth is supposed to be a trust mechanism, but when implemented poorly, it does the exact opposite. And trust, once lost, is nearly impossible to rebuild. If a user's first exposure to MCP is a confusing setup and unhelpful error messages, they're not going to think, oh, this particular implementation is rough. They're going to think MCP is confusing, it doesn't work. A poor end user experience today becomes a reputation problem for the entire ecosystem tomorrow. The irony is that MCP was supposed to make innovation simpler. And then there's the paywall issue. This one's frustrating because it undercuts the entire ethos of an open standard. Just to test your own MCP server in ChatGPT or Claude, both developers and users need paid subscriptions. That means the ecosystem isn't just fragmented, it's financially gated. A developer building an open source MCP server for their community has to pay monthly fees to make it testable. Users who want to connect to it have to do the same. That's not open, that's open if you can afford it. And when experimentation is limited to a small pool of paid users, feedback loops slow, community engagement dies, and progress becomes centralized in the hands of a few large vendors. That's not what MCP promised, and that's not what anyone here wants to build. Now, this is a security conference, and I would be remiss if I didn't mention some serious security issues with the state of MCP today. I'm not a security expert, but there are 3 items I need to address here because all developers should always work with security in mind. First, prompt injection. SQL injection's newer, younger brother. Prompt injection is an exploit where malicious users provide input to AI applications that appear to be system instructions and can manipulate AI agents and systems to bypass safeguards and execute malicious tasks for the attacker. This is prevalent in the world of MCP because MCP servers can expose any type of information as prompts or resources to the end user's client. Second, tool permissioning. There was an exploit reported a few months ago known as tool poisoning attacks, where malicious instructions are embedded within MCP tool descriptions that are invisible to users but critical to the AI models. These hidden instructions can manipulate AI models into performing unauthorized actions without the end user ever knowing. These include anything from leaking sensitive information to the attacker to hiding the actual actions carried out by the model behind simplified UI representations of tool inputs and outputs. And lastly, how lookalike tools can silently replace trusted tools. MCP clients constantly list the tools available to them from their connected servers. However, multiple tools can share the same name. A malicious server could expose perfectly safe tools, such as Echo or Dice Roll. But once trusted, it could expose a new tool that hijacks the name of a trusted tool from a different server, such as push files. The next time the model pulls all tools into its context, the malicious push files tool could overwrite the trusted push files tool because only one name could fit in the context, and the user could unknowingly push their files to the attacker instead of their trusted repository. These examples aren't theoretical edge cases. They're symptoms of how young MCP still is. The ecosystem is evolving fast, but its security story hasn't caught up yet. Unlike mature web standards like OAuth 2.0 or HTTPS, MCP doesn't yet have a well-defined threat model, permissioning layer, or isolation boundary between clients and servers. That means we, as early builders, are the first line of defense. Every new MCP integration effectively becomes a new surface area for attack. And because the protocol is designed to expose tools and resources directly to AI systems, the blast radius is much larger than a typical REST API. As developers, we need to apply the same rigor we would to any production API. Strict input validation, tenant isolation, auditable logs, and continuous monitoring of what our agents actually do. Because in MCP, the attack vector isn't just the network, it's the model itself. So while MCP's openness makes it powerful, that openness also makes it fragile. The developers who treat security as a first-class design principle, not an afterthought, will be the ones who make MCP sustainable, trustworthy, and ready for real-world production use. Now some parting thoughts. MCP is great, genuinely great. It's rare to see so many builders rally around a new protocol this quickly. But it's also important to be honest. MCP is still less than a year old. The pain points we've talked about today, authentication chaos, fragmented SDKs, unclear tool routing, rough user experiences, and security blind spots, they're not signs of failure. They're signs of growth. Every early technology goes through this phase where enthusiasm outpaces infrastructure, and that's okay. That's what progress looks like in real time. What matters now is how we address these challenges. Instead of patching over them, we can use this opportunity to define what production ready means for the whole ecosystem and build something long lasting. MCP is young, and its future depends on what we build right now. Thank you.